Hello and welcome everyone. This is the video where we look at the previous year's IIT JEE Advanced questions on complex numbers. Right? So we will look at last 5 years questions on the topic of complex numbers. So we'll see that most of these require just some ideas, basic ideas only, and then we'll also see that how these ideas translate in terms of geometry, and we'll see like how to solve them using geometrical ideas especially. So we'll actually move in the reverse order. So we'll start with the problems from the year 2021, and then I'll move on to the year 2020, then 19, 18 and 17. So we'll look at last 5 years problem. So let's look at first the problem from IIT JEE Advanced 2021. So this appeared in paper 1. Okay, so the problem is as follows, that we are given that alpha and beta are real numbers. Okay, so alpha and beta are in R, they are reals, and then we know that we are given that every complex number z of the form x plus iota y, so x is the real component, y is the imaginary component, which satisfies argument of z plus alpha by z plus beta is pi by 4, then x comma y lies on a circle, right? And now we are being asked about these values of alpha and beta. So if you look at this thing, right, argument of z plus alpha by z plus beta equals pi by 4, the first thing you may want to try is that you might want to substitute it as z equals x plus iota y. Then you can compute this ratio and then see what is the form of the argument. But actually all that also can be done, but there is a very simple way. So the thing is that we know that it lies on a circle, and here this equation also appears that actually z should lie on a circle. The reason is as follows, that let's look at the problem geometrically. Okay, so we know that alpha and beta, they lie somewhere on my real axis. Okay, so this is my real axis and this is my complex argand plane, and then I have this point z, and now notice that z plus alpha, if I want to write, so z plus alpha equals z minus alpha. Okay, so maybe it makes more sense to plot minus alpha and minus beta on the real axis, and then in this case z plus alpha is going to be the vector which joins minus alpha to z, so in the direction of z. So this vector is going to be z plus alpha. Similarly, the vector joining minus beta to z is going to be z plus beta, right? And what we know is that the vector z plus alpha makes an angle of pi by 4 with the vector z plus beta in clockwise, basically in anti-clockwise positive sense, right? Because that's the standard convention. So this was the vector for z plus alpha, this is z plus beta, and the angle between them is now pi by 4 or 45 degrees. And notice that the same is the constraint which is satisfied. Suppose if you have a circle and you have a segment or a chord in the circle, then any angle which it subtends on the arc equals the same value, right? So if this is theta, then all these angles are essentially theta. So here also we are given that such a condition is met, and the locus of points which satisfy this condition is essentially a circular arc, right? So this is the circular arc which satisfies this sort of condition. And so basically this is an arc of which the chord is minus alpha minus beta, and it essentially lies on a circular arc, right, at which we have minus alpha and minus beta, and this angle is pi by 4. Note that the chord joining minus alpha and minus beta makes an angle of twice of pi by 4, which is pi by 2 at the center, right? So this angle at the center should be 90 degrees. Okay, and now we are already given that this is a circle, right? So as expected, I know that this is a circle, and now I'm asked to find out, what are the possible values of alpha and beta, what conditions do they satisfy from this equation of circle. So note that if I already know the equation of a circle, and then basically minus alpha and minus beta are the points which are cut when the circle intersects x-axis. So let us see what happens when the circle intersects x-axis. So the circle which we are given is x square plus y square plus 5x minus 3y plus 4 equals 0. Okay, and we know that equation of x-axis is y equals 0, right? So essentially we can just substitute y equals 0, so all these y terms go away, and basically these points minus alpha and minus beta, they satisfy the condition that x square plus 5x plus 4 equals 0, which means that x plus 1 times x plus 4 equals 0, or basically x equals to minus 1 comma, so x equals minus 1 comma minus 4, right? And now I don't know which one is now alpha and which one is beta, but notice that minus alpha and minus beta are the points lying on x-axis, and we know that it is z minus alpha which is making an angle which is say in the clockwise direction from z minus minus beta. So z minus minus alpha, which is z plus alpha, is making a in anti-clockwise positive angle with z plus beta. So therefore we know that minus alpha must lie to the right and minus beta must lie to the left. So minus alpha should be like, so here we know that x can be either minus 1 or minus 4, right? So these are like minus alpha and minus beta points. So basically I know that now that minus alpha can be like minus 1 and minus beta should be minus 4, right? Because we know that minus alpha should lie to the right of minus beta. That's why it's making a positive angle. So therefore we have minus alpha is minus 1 and minus beta is minus 4, right? So basically alpha is 1 and beta is 4. So we have solved for alpha and beta. And now let's look at the options. So it says which of the following are true. So firstly we see that alpha beta is definitely 4. This is true. And we also see that beta is 4. This is also true. And we see that alpha is 1, right? So minus alpha is minus 1 because these points on x-axis are which we plotted were minus alpha and minus beta, right? So let's move ahead to the next problem. So let's see another problem. So this also appeared in the year 2021 in paper 1. So here we are given that there are some positive angles, positive valued angles. Okay. So basically these are all positive and such that their sum is going to be 2 pi. Next we define complex number z1 as e to the power iota theta 1. Okay. So z1 has unit magnitude and it lies somewhere on this complex circle. Then next we have that for k equals 2, 3 up to 10, I have zk equals zk minus 1 times e to the power iota theta k. So basically like it's like z2 being e to the power iota theta 2 times z1, z3 is e to the power iota 3 theta 3 times z2 and so on up until z10, which equals e to the power iota theta 10 times z9. So basically if I have to plot z2 here, it will lie and it will make an angle of z2, it will make an angle of theta 2 with z1, right? So they will all lie on this unit circle. And finally I have that z10 is e to the power of theta 10 times z9, right? So essentially if you see, my z10 is going to be like z9 times e to the power theta 10, which equals z8 times e to the power theta 9 times e to the power theta 10, right? And so on. If I like continue, I'll see that z10 is going to be z1 times e to the power theta 2 up to e to the power theta 10, which equals e to the power theta 1 times e to the power theta 2 up to e to the power theta 10, which is nothing but e to the power I times sum over j theta j, and this we are given that this also equals 2 pi, right? So this is going to be 1. So Z10 is going to lie at 1. So Z10 we know is 1. Okay, so we are given now 10 points on this circle, and now we are given two statements P and Q. So the first says that mod of Z2 minus Z1 plus Z3 minus Z2 up to Z1 minus Z10 is less than equal to 2 pi. So basically this mod of Z2 minus Z1 is the length of the chord joining it's the length of the chord joining Z1 and Z2. Next we have the length of the chord joining Z2 and Z3, and so on until we have finally the length of the chord joining Z10 and Z1. So we have the length of these chords, and we are given that this is less than equal to 2 pi. So let's look at the first assertion, which is P, and let's see whether it's true or not. So there's two similar assertions, P and Q. In Q we have similar to P, but now the complex numbers are replaced by the squared values, and we need to tell which one is true and which one is false. Okay, so let's look at the assertion P first. So here we are given the length of the chord, and the assertion states that the sum of these lengths should be less than equal to 2 pi. So let's see whether this is true or not. So now if we see, suppose if I look at the chord joining say Z1 and Z2, okay. So mod of Z1 minus Z2. So now we know that Z2 is going to be Z1 times e to the power theta 2, right? And we have Z1 times 1 minus e to the power theta 2. So notice that all these points, they lie on this unit complex circle, right? So all these Zi's are going to be 1. And now we have to compute these values, right? And actually there is a standard way to compute it, which is that you can take out e to the power iota theta by 2 common. So note this trick. So this will be used in a lot of problems, that whenever you see like 1 minus e to the power iota x sort of a thing, you can try to take out e to the power iota x by 2 out, and next you will see that this is going to be e to the power minus iota theta by 2 minus e to the power iota theta by 2, and the mod of this thing. And this quantity is unit mod, so you know that mod AB is equals to mod A times mod B, so this is 1. And now we are left with the other part, and this, if you see, this is just minus twice I sine theta 2 by 2, right? Because this is a negative of negative iota times twice the imaginary component of e to the power iota theta by 2, right? Because if I want to compute them, if I want to do like z minus z conjugate, I get twice iota times imaginary part of z. So this is what we have gotten, and this is nothing but twice times mod of sine theta 2 by 2, right? And theta 2 is positive. So yeah, so basically, yeah, so this is the magnitude of this theta 2, and we now know that mod sine x is less than equal to mod x, right? So you can see from the figure of sine x also that the mod value of sine x, the positive part of sine x, you see that it's always lies below x, and the negative part is always greater than equal to minus x. So basically, yeah, so if you compute like mod sine x, which will have the positive part only, then it will be less than equal to mod x. So essentially what we have done is that so we have said that the length of these chords is actually less than equal to the length of the corresponding arcs, right? So you can actually give it a very geometric interpretation also, because the length of each of these chords is what is given by mod of z2 minus z1 or zk minus zk plus 1, and the length of these arcs is given by just the theta case. So because these arcs are in radians, so you can see that length of chord is also always less than equal to a length of arc, and so basically this chord length is less than equal to theta 2. Similarly, similar logic if I apply, then I'll get that the remaining chords, they are also less than equal to theta 3, theta 4 up to so on, and this chord is nothing but this subtends an angle of theta 1, so here this is less than equal to theta 1. So the sum of these chords is less than equal to their corresponding arc lengths, which is up to theta 1, and it is equal to 2 pi. So you can look at it both in terms of geometrically or in terms of algebraically. Also we saw that 1 minus e to the power iota theta is less than equal to theta in terms of magnitude. So if each of these is less than equal to their corresponding theta case, then if you sum them up, that will be equal to 2 pi. So the sum of these chords lengths is upper bounded by 2 pi. So definitely P is 2. Now let's look at the assertion Q. So in assertion Q, what we have is that the points are replaced by the squared values. So if you replace the points by the squared values, it's just that the angles and the differences are now going to get doubled, because these are unit magnitude complex numbers. So if you square them, they'll still remain unit magnitude, but the angle, the argument will get doubled. So if the argument will get doubled, the difference of arguments is also going to get doubled. And essentially, now what is going to happen is that this mod of z2 square minus z1 square, this is less than equal to twice of theta 2, next you have twice of theta 3 up to so on, and then you have twice of theta 1. So this is actually equal to 4 pi. So Q states that the sum of differences of squares is upper bounded by 4 pi, but that is also true, right? So both P and Q are true. C is the right option. Right. So just think about it, work out the Q part also. So it's just a similar logic, right? So I didn't actually derive the entire result for Q, but the idea is similar, and you should actually try to complete that yourself. So let's see the next problem. So this is from now IITJEE 2020, JEE Advanced 2020. This is also in paper 1. And it says that, so suppose S is the set of complex numbers which satisfies that mod of z square plus z plus 1 is 1, then which of the following are true? And we are given some inequalities. So again, whenever you see that, okay, you are given that this is of unit magnitude, then it makes sense to assume that, okay, so let z square plus z plus 1, so let this be equal to e to the power iota theta, right? And I can assume that theta lies between, say, minus pi and plus pi. And now this is now a quadratic equation. I can actually solve for z. So I'll get minus 1 plus minus square root of, okay, so I can take this to the other side. So I have b square minus 4a times c over 2a, right? So this is like minus half plus minus square root of minus 3 plus 4 e to the power iota theta by 2. So the set of these complex numbers are of this form. Okay. So firstly, we see that what is mod of z plus half. What can we say about mod of z plus half? So z plus half is going to be plus minus square root of minus 3 plus 4 e to the power iota theta by 2, or mod of this thing is going to be mod of this thing, which is going to be half of mod of square root of minus 3 plus 4 iota theta, right? And we know that the mod of root z is going to be square root of mod z. So here we can actually take mod inside the square root. And if we look at now this quantity, this expression minus 3 plus 4 e to the power iota theta, the magnitude of this thing, we can check that this magnitude actually lies between, okay, so minus 3 plus 4 e to the power iota theta. So if I apply, say, okay, so basically this lies between, so here if I have a point, say minus 3, and I draw a circle of radius 4, right? Yeah. So essentially it will go something like this. And now the least magnitude point, right? And the most highest magnitude point I need to find out. So the highest magnitude will actually occur when minus 3 and 4 e to the power iota theta, they are like parallel to each other. And the least magnitude will occur when they are anti-parallel to each other, right? So the magnitude of this will be at max 7, right? This is when they are in the same direction, and it can at min it can go to +1, right? Because this is when they are pointing in opposite direction. Or even in general, you can apply the inequality that mod of z1 plus z2 is less than equal to mod z1 plus mod z2, right? So the mod of minus 3 plus 4 iota theta is less than equal to 3 plus 4, it is 7. And also we have a similar inequality that mod of z1 minus z2 is greater than equal to mod z1 minus mod z2 mods. So these are two forms of triangular inequalities. If I apply this one, I'll get that. So let us say that I put z1 equals 4 iota power iota theta, z2 equals 3, then basically I'm going to get this is greater than mod of 4 minus 3, which is 1. So basically we see that this expression lies between 1 and 7. So what we had now is that mod of z plus half, this lies between, so this lies between where to where? So it lies between square root of 7 by 2 and it lies between half. So it lies between half and square root of 7 by 2. So it's definitely not less than equal to half, it's only greater than equal to half, right? And for all z in S, yes, this is true. And what can I say about now mod z? Okay, so now if I look at mod z, where should it lie? So I know that mod z plus half, actually it lies on this sort of circle, right? And so where can now z lie? So for that I can say that mod of z equals now mod of z plus half minus a half, right? So which is less than equal to mod of z plus half plus half. And mod z plus half, I just find out that it is less than equal to root 7 by 2. So overall this is less than equal to root 7 by 2 plus half. And we know that root 7 is less than equal to root 9, which is 3. So this is less than equal to 3 by 2 plus half, which is 2. So mod z is less than equal to 2. So hence this is also true. Now it says that the set S has exactly 4 elements, right? But as we see, we have computed an expression for this set, and for every theta I'm going to get a new value. So definitely it has like infinite number of elements. The set S which satisfies this equation has infinite number of elements, right? For every theta I'm going to get a new element. And so this definitely has more than 4 elements. So this D is wrong and this A is also wrong. So here we have B and C. So this is a multi-correct question. We have 2 correct answers, B and C. Yeah, so convince yourself, do those arguments yourself and you will be able to figure out the 2 correct options. So let's move on to the next question. Now this is again from 2020, but this is now in paper 2. So this is the first problem. And here we are given that for a complex number z, real part of z is denoted as re z, and S is the set of all complex numbers which satisfies this equation. Okay, so we are given some equation in this complex number which is say z to the power 4 minus mod z to the power 4 equals 4 iota z square. And we are given that S is the set which satisfies this set of points which satisfy this equation. So iota as before is always square root of minus 1. Then what is the minimum possible value of mod of z1 minus z2 squared, where z1 on z2 both belong to this thing, both belong to this set, and such that real part of z1 is positive and real part of z2 is negative. Okay, so we are essentially now given an optimization problem that we need to minimize z1 minus z2 square, and we are given the constraints that z1 is belongs to S, z2 belongs to S, and real part of z1 is positive whereas real part of z2 is negative. So so basically let's see, it looks like a difficult problem, but we'll see that how we can use some geometric ideas and some algebraic identities, and then we can solve this problem very easily. So let's look at the objective function again. So basically we are given that z to the power 4 minus mod z to the power 4 is now 4 iota z square. Okay, so let's try to solve this sort of equation. So suppose let z be equals to r e to the power iota theta, because so we are given actually mod z, and now it looks that as if the equation might get simplified if I assume like the argument and magnitude form. So this often helps us, right? And especially because if you want to compute powers, right, so x plus iota y to the power 4, if I want to compute that will be really difficult. But here in this argument and magnitude sort of form, it's easy to compute magnitudes and it's also easy to compute powers. So that is why we, instead of going x plus iota y, start with this sort of assumption. So let's substitute this. So if I have to compute z to the power 4, I'm going to get r to the power 4 times e to the power iota 4 theta, right? Because if I just take the powers of z1, z2, it's z1 to the power 4, z2 to the power 4. And now mod z is going to be r. So mod z to the power 4 is going to be r to the power 4. And this equals 4 iota times z square. So z square is also now equal to r square e to the power iota 2 theta. Okay. Okay. So far so good. So let's take out r to the power 4 common, and now I have e to the power 4 theta minus 1. And notice we actually, in one of the previous problems, we did some simplification, wherein when we had the points on the circle, what we did was that I had made sort of an so what I did was that I expressed 1 minus e to the power iota theta as 2 iota sine theta by 2. And the way either you can remember that as an identity, or what you can do is that you can always take out common as e to the, suppose if you're given like 1 minus e to the power iota x sort of expression, so you can always take out e to the power iota x by 2 common and then see what happens. So we will do that again. And here we just have r square e to the power iota 2 theta. So let's actually cancel out r square. And note that when we are cancelling out r square, we need to ensure that this z is actually non-zero, because so if you substitute z equals 0, that also satisfies this equation. But since we are given that real part of z is positive and real part of z2 is negative, we are only restricting ourselves to non-zero solutions. So that is why I could cancel out r square. Okay. And now if I take out e to the power iota 2 theta common out, I get e to the power iota 2 theta minus e to the power minus iota 2 theta, and this equals 4 iota e to the power iota 2 theta. So this e to the power iota 2 theta can also be cancelled out, and now I get r square times twice iota sine of 2 theta. Okay, and this is equals 4 iota. So I can again cancel out this thing, and now I get equation r square sine 2 theta is 2. So now you may think that, well, how do we solve such an equation, right? Because there is a sine part, there is angles, there are magnitudes. But one thing which you can simplify is that let's open out sine 2 theta, right? So this idea is actually very essential. So essentially, see, when we were solving this problem, so this thing is quite standard, 1 minus e to the power iota theta and dividing and multiplying by e to the power iota theta by 2, that's one of the standard tricks. But now we are actually going to do something non-standard. So what we'll do is that we'll take this phase angle representation and we'll try to convert it back to real and complex parts. Because actually the problem statement here, if you see, we need to basically look at the points where real part is positive and negative. So let's actually try to go back to that. And now, okay, so it may appear difficult, but now once you have expanded out sine 2 theta, you can actually break it as r sine theta, okay, times r cos theta. This is going to be 1. And r sine theta is nothing but the imaginary component y, r cos theta is nothing but the real part x. And essentially I am now getting xy equals 1. Okay. And now xy equals 1. Now for that we know how does it look geometrically. This is just a rectangular hyperbola. Right? So this is the equation of xy equals 1. Right? This is y equals 1 by x. So if we now look at such an equation, what we can see is that so basically we need to look at now the points which lie on these hyperbolas, but we need to look at the points wherein so we need to look at the points. So we need to look at one point z1 where the real part is positive, where x is greater than 0, and one point z2 where the real part is negative. And we need to look at the closest pair of points where one part is in the upper hyperbola, the other part is in the lower hyperbola, right? But if you see, the axis of this hyperbola lies along y equals x. So this is the axis, and the parts in the upper and lower hyperbola which are closest to each other are the ones which intersect this axis. For the other parts, the distance is definitely going to be larger. And the parts which actually intersect this axis, the points which intersect this axis are 1, 1 and minus 1, minus 1. We know that the distance between them, yeah, so we can actually compute that the distance is going to be twice of root 2, right? So it will be like 2 square plus 2 square under root, which is 2 root 2. And so the square of the distance is going to be 8. This is 2 root 2 square. So the minimum possible value is 8. Right? So this is definitely one of the difficult problems, and if you see, so you need to practice these sort of problems to be able to guess like which identity to apply. So we saw that when we had 1 minus e to the power iota 4 theta or e to the power iota 4 theta minus 1, we got the idea that we can take out common e to the power iota 2 theta. And actually the other thing we got the hint was because it's on the right side. But here, this idea should also strike you that, okay, we are given its r theta form, we need to go back to xy form. And then if you substitute sine 2 theta as 2 sine theta cos theta, you can again recover x and y. And that will help you solve the problem, right? Because we could proceed to the hyperbola only once we saw this sort of form. Okay. So we have a few more problems which we will continue in the second part of this video. So thanks for watching, and also do keep trying to attempt these problems yourselves before looking at the solution. Yeah, thanks. We'll continue this in the second part.